Okay, good morning, everyone. Please, can I have your camera on? Okay. All right, good morning. Okay, questions? How did the homework go? Do you guys have any questions from the homework? Any questions, anyone? Okay, so we keep going. So yeah, last time what we did was we talked about the 2 units of measurement of an angle. And we talked about the 2 units we have. So we have a radian and we have degrees. And the conversions was pi radian is 180 degrees. Okay, and I kept reminding you that pi is actually a number. So it means a little bit, in 180 degrees, you have a little bit more than 3 radian. So you have to keep this in mind. So radian does not stay totally an abstract idea for you. Okay, all right. So I see one question and I will proceed. So go over number 18. What angle in radian correspond to the given number of rotation? Okay, so we will do that and then we go back to the lecture. So the question is, okay, if you have, so that's 6 circle, so that's number 18 in the book. Okay, and the question is, I read it again. What angle in radian correspond to the given number of rotation about the unit circle? So it means I think if you go that much rotation, it means 3/4 of a rotation around the circle. So that's the center, that's my circle. So it's not a complete rotation, 3/4 of a rotation. What is the angle in radian that you perform? So what do you really mean by 3/4 of a rotation? It means you start here and you don't make a full rotation. So that's 1/4 of a rotation. That's really what they mean. That's 2/4 of a rotation. And that's 3/4 of a rotation. That's what they mean by 0.75 rotation. It means not a complete rotation. So the question is, what's the angle here? Rebecca, can you answer the question now? Rebecca, are you with me? Yeah, exactly. In radian, because they want it in radian. In radian, 270 is how much in radian? How much is 270 in radian? Okay, remember? 90 is, that's the one that you should memorize. 90 is pi over 4. 270, 3 of them. Pi over 4 plus pi over 4 plus pi over 4. That will give me 3, my apology. 90 is pi over 2. So pi over 2 plus pi over 2 plus pi over 2. This would give me 3 pi over 2. Okay, so that's 3/4 of a rotation. Now, when we write 3 pi over 2, I don't have a unit. This is mean radian. So usually a lot of time, if they don't put a unit next to the angle, they mean radian. For degree, they have to put the unit. That's how it works, okay? So that's really the answer to this problem. That's really what they mean by rotation. Okay, any other questions? So back to what we were. So that's the main conversion. And then last time we start, doing the little ones. And I thought you should basically memorize them. So 30 degrees was pi over 6, because if you remember, 30 is basically 1/6 of 180. And then 60 was pi over 3. And then we kept going, 122 pi, 135, 3 pi, 155 pi over 6. So that's what we did last time. And I urged you basically to memorize the basic ones. All right, as a little bit of a reminder, I want you to do the following problem before we proceed to the new material. Okay, so here I have a table. I'm giving you the angle in degrees or in radian, and I want you to fill in those blank spots. Okay, so get going. And I don't want a calculator. It means I don't want you to, mainly I want you to use this, that basically what you know. So what I want you to use, only those. So I want you to use, okay, the very common one. It means I want you to use those. Pi over 4, pi over 6, pi over 2, 0, 30 degrees, 45, 60, 90. Okay, I want you to use the basic conversion to fill in that. Okay, get going, and I still start asking you as you guys do it. Okay, every one of you should do it. Every one of you. Okay. All right. How's it going? Okay, I'll start with the first one, which is probably the hardest one. 15 degrees in radian. Who would like to answer?
Is it pi over 8?
How did you get that?
Okay, well, I saw that pi over 6 is 30 degrees and
Right.
pi over 4 is 45 degrees. So it's going up by 15 degrees each time you divide pi by an additional 2. So I assume that if you subtract 15 degrees from 30, then it must be pi over 8 for 15 degrees. Right?
So
Just
you're
based on
going.
that?
So you're going like here.
Right.
And then what are you doing here?
Well, I thought I explained it, but
Yeah.
mathematically, I don't.
Think about, okay, forget about pi over 4. Relate those two.
It's half. Okay, 15
Right.
degrees is half of 30
Yes.
degrees, right?
Right. So what's a half of pi over 6?
Pi over. Wait, would pi over 8 be half of pi over 6?
No. If you take a 6 and you divide it into, so if you take a 6 and divide each one into 2 pieces, that's what a half of it. You get how much?
Pi over 12. Did somebody?
Right, it's half pi over 12. So it's a half of pi over 6. It's pi over 12. You don't add, you multiply. Okay,
Oh, okay. I was confused because
go ahead.
I was confused because it looked like it was going up by 15 degrees each time. But
Yes, but the difference here, you have to compute the difference between pi over 4 and pi over 6. If you want to think along the lines you're thinking. So you have to see how much this is going up by. To do that, you have to take the difference between pi over 4 and pi over 6. And you will get here pi over 12.
okay.
That's how you, what?
I said, okay.
Yeah.
I didn't understand at first, but
Yeah, that's how you should do. So if I follow you, you're right. From here to here, 15. But from here to here, you have to compute the difference, which is pi over 12, if you do the math correctly. Okay, but that's easier. Okay, so it's a half of pi over 6, pi over 12. Okay, that's the hardest one. The rest should be easy. Okay, what should I put here? Anybody would like to answer before I pick?
150 degrees, Professor.
106.50, absolutely correct, because, very quickly,
Pi over 6 is 30, and if you times 5 by 30, it gets
you're
you
done. Absolutely correct. It's 5 times 30, because pi over 6 is 30 degrees. 5 pi over 6 is 5 times 30. That's the simple math I want you to do. 210, anybody else? 210 in radian. So that's it. That's the only thing I want you to use. So I'm going to erase the stuff here.
It's 7/12 pi.
Right. It is 7. So 210 is 7 what? Keep going. You're right. 210 is 7.
I said 7/12 pi. I don't know what you're.
What do you want me to write here?
7 pi over 12.
Why?
No.
Yes, no.
Um.
210
Because
is 7 times what?
7 times 30. I apologize.
Right. So what
I
should
wasn't sure.
Okay, no, you have to do the math. Nothing. It's no magic. It's the math. So this is 7 pi, let me write it like this. It's 7 pi over 6.
Yeah.
Right?
I apologize. It was.
No, you don't have to apologize. Okay. I don't know why I put 7 pi over 6 again. My apology for that. That's not what I want. I want 7 pi over 3. Sorry. 7 pi over 3. Now back to you. Actually, I wanted 4 pi over 3. I don't know why I messed up this problem. Okay, 4 pi over 3, quickly. In degrees.
240. Yep.
140, absolutely. Why? Pi over 3 is, oh boy, pi over 3 is 60. 4 of them is, 4 times 60 is 240. 270.
3 pi over 2.
Because you're right, just tell me always the reason so everybody understands.
I honestly forgot how I got there, so give me 1 second.
Sure. But I want you to be able to move back and forth. Those are what we call the common angles. So I want you to really go back and forth easily between them. 3 pi over 2.
Okay, so it's because, so I know that pi over 2 is 90 degrees.
Right?
And if you times that by 3, then you get 270.
Right. Simply because 270 is 3 times 90. Okay? 300.
5 pi over 3.
5 pi over 3 because 300 is
60 times 5 because pi over 3 is 60 degrees.
right. That's 5 times 60. So that's 5 pi over 3. And 11 pi over 6.
$330.
330. Because that's 11 times 30. 11 times 30, that's 330. Okay. So 11 pi over 6 is basically 30 degrees away from the positive x-axis, 30 degrees away from the positive x-axis. Right? So on my number line, on my circle here, basically I will finish filling it out for you. 180, that's 210, because I'm adding 30 every time. 210, now 210 is, which it's 730, so that's 7 pi over 6. Another 30, so that's 240 degrees. 240 degrees is 4 times 60, so that's the 4 pi over 3. That's the 270, which is the 3 pi over 2. I mean, this picture has to be, you know, if you know in trigonometry, everything we're going to be doing today and next time, absolutely the basics. So, and right here, I am at 300. 300 is 5 times 60, so that's the 5 pi over 3. And finally, the last one here, I put it this way. That's the 330, and this is 11 pi over 6. Means we are 1 pi over 6 away from the x-axis. All right, so that's really the whole picture right there. Okay, radian degree, radian degree. So before we go back to sine and cosine, there is one benefit of, I mean, there are a lot of benefit of radian. Actually, it's radian, as I told you last time, several times, is the unit we use in calculus. I mean, this is the unit because it's this geometrical. But before I go back to sine and cosine later on, I want to talk about something called the arc length in circle radius r, arc length. In circle of radius r. Okay, sorry. Arc length in circle of radius r. When you don't see a paper, please let me know, because sometimes I'm writing, I don't pay attention. The idea is the following. Let us remember what the radian was from last time. What was the radian? I mean, how did I tell you a radian is? A radian is the following. You start with the unit circle. Then you take an arc of length 1. That's the radian. That's the radian. So this from here to here, this is 1. Okay, that's what the radian is. So the idea now, if you take a bigger circle, so you take the same angle, 1 radian, but you blow up the circle. So the radius now is r. From here to here now, it's r. The angle is the same, it's 1 radian. But of course, this arc here is definitely bigger than 1 because we stretch the radius by the radius r. So what happened to this arc here is going to be stretched by the same amount. If we stretch the radius by r, this will be r unit. Whatever the radius is, the length of this arc is going to be r this time. So the 1 radian, if you have circle of radius 1, this arc is 1. If you have a circle of radius r, this arc will be r. It's going to be stretched by the same amount. And the idea keep going. Like let us say I take half a radian. So if I am on a unit circle, and if I take half of a radian, it means this here, so it's half a radian. This is also half a unit. So the idea that if you stretch by, take a bigger radius, a bigger radius. So the angle is the same here. This is a half. This is going to be much bigger if you basically draw the picture. And this is going to be half the radius. If this is a half, this is half the radius unit, whatever your unit is. Okay. So what is the picture in general? The picture is the following. So in general, we have the following idea. It's actually simple. Okay. Suppose you have a circle, any circle, not unit anymore, of radius r. So radius r. Okay. And you have an angle. It doesn't have to start at the origin, actually. It can start anywhere. You have an angle. And this angle here is theta, but it is radian. And the unit here is input, it's radian. So this angle is going to cut an arc. We're going to have arc here. Imagine yourself, you're walking from here to here, and the angle at the center is theta. Then the length of this arc, is the angle times the radius. Okay, so as long as the angle is measured in radian, because if you have 1 radian here, this is our unit. If you have half a radian, that's r over 2. So the idea, if you have theta here, that's going to be theta times r. That's the idea. So this arc here, its unit, its measurement is theta r, as long as my angle is in radian. In degrees is not correct, absolutely not. So the way the book writes this is tells you the following. The length, and they use the letter S. You have to be familiar with it to denote the length. The length S of an arc. That's what I mean by arc. It means you take this arc and stretch it and measure it. That's really what to mean length. So the length S of an arc cut off by an angle theta at the center, by an angle theta in radian. So if the unit of the angle is radian, on a circle of radius r, is given by S equal, the length is the radius times the angle. And the crucial thing that this is true if the angle is measured in radian. Okay, so it's a simple application of radian, which is actually an interesting application. It means if you know the angle here, and you want to know what's the length there, it is telling you, okay, you take the angle, as long as it's in radian, you multiply it by the radius, and you have the arc. So that's two small applications to this, simple ones. So question number 1 is find the length of the arc in the given cases. So example 1. Find the length of the arc in each case. Okay. So we're going to find the length of the arc in the given cases. So, okay. So I'm going to take the first case. Suppose I have a circle and the radius is 2, for example. So it's important to know the circle of radius 2. And suppose I have an angle here, let us say pi over 3. Okay, and my question is find the length of this arc. So I'm going to use the formula verbatim. The length is, so that's the length I am after. So that's the length which is cut off by the angle pi over 3. The radius is 2. So the formula tells me Pi over 3 is in radian. When I don't put the unit, it means it's radian. So the length is the angle, the radius, times the angle. It means 2 times pi over 3. It means if you take a circle, circle radius 2, you take a 60 degrees angle, or pi over 3, and you take at this arc and you measure it, you actually get that much unit. And now this could be computed using your calculator, which is, you guys can do it. All right, example number 2. Suppose I'm going to take again a circle of radius 2. Okay? Circle of radius 2. Okay. That's my circle. Okay. And I'm going to take an angle. So I'm going to cut off this angle from here to here. And this angle is 70 degrees. Okay. And the question is, suppose you start walking from here to here. You walk, you start at this point, you keep walking, and you stop here. The question is, what's the distance you've walked? In other words, what's the length of that? That's really what this problem is about. What's the length? Now, here's the problem. The formula I gave you works as long as the angle is in radian. If the angle is in degree, I cannot use r theta. So this works if theta in radian. Crucial. When I give you the angle in degree and you want to measure this length, what you have to do is to convert degree to radian and then use the formula. Okay, so it means the length is not 2 times 70. It's not 140. It's out of the question. So to find the length, so since, let's see, we have start by converting 70 degrees to radian. The formula works as long as the angle is in radian. Now let us see what the conversion is. Let us remember. Do you guys remember the conversion? So 1 degree is how much in radian? You guys remember it? Anybody? Pi over 80. 1 degree is pi over 80. If you ever forget that, you don't have to memorize it. Just remember this. 180 degrees is pi. So 1 is pi over 180. So that's really what you have to know. And then you can figure this out. Now 70 degrees. 70 degrees is 70 times pi over 180. So let us see how much in radian. And this time I will pick up my calculator and compute it to 3 decimal because I want you to have an idea. So basically I'm doing 70. You guys do it with me because you're faster on your calculator than I am. Times pi. I'm going to divide this by 180. And I'm getting a little bit over 1 radian, which makes sense because a radian is almost 57 degrees. So 70 degrees, a little bit more than a radian. So 1.22 17. Okay, we're rounding to 4 decimal places. So that's in radian. Now, once I know how much this is in radian, now I can use the formula. So now the arc length of the arc is equal to the radius times the angle. And this will give me 2.4434 unit, whatever the unit is. So if this is in centimeter, it means the length here, so the length of that is 2.4434 unit. Centimeter, centimeter. Feet, feet. Miles, miles. So whatever your unit here, the arc will carry the same unit. Thanks, Giselle. Okay. Any questions? Right. Okay. Now, so that's, you know, it's a simple idea, but it's very important. I mean, it's really a simple but important idea. Now we're going to go back to sine and cosine. We never leave those. And we are going to do the following. We have all those angles, common angle. Our goal now is to find the sine and cosine of every one of them. Okay, I'm going to give you the basic one that you're going to memorize. And once we find the basic one, we're going to figure out how to compute all the rest. So now back to sine and cosine of basic angles. So sine and cosine of, so sine and cosine of basic angle or common angle. Of common angle. Those, okay. All right. I start with the basic angles. That's the one that I want you basically to memorize by heart. So let's see what the common angle are. So theta, the angle, the theta in degrees. In degrees, theta in radian, the sine, and the cosine. Okay. The basic, the one that I want to memorize are 0, 30, 30 degrees, 45, 60. And then 90, we should be able to do it easily. 180, you don't need to memorize it, you should be able to figure it out. Okay. Actually, we should be able to figure out 270 as well. Okay. The three that you need to memorize are those. Now in radian, that's a 0. That's a pi over 6. That's a pi over 4. That's a pi over 3. That's a pi over 2. That's the pi, and that's 3/90s, which give it a 3 pi over 2. Now the sine and cosine. I have to start asking you. The one that you know, I will ask you to give it to me. The one that you don't know, okay, I will give them to you. All right, what's the sine of 0 quickly? Remember, you want sine of 0, you take your unit circle and you ask yourself, okay, what's the point? So that's the unit circle. What's the point on the unit circle that correspond to angle of 0? That's the point. What? So what's the sine quickly?
0.
0 is the y coordinate. What's the cosine quickly?
1.
1.
1.
These are the one I want you to be able to always figure out. Now, 90 degrees. What's the sine and what's the cosine? You ask yourself which angle on the unit circle correspond to 90. That's the point on the unit circle. 0, 1. So the sine of theta is, Jeremiah, quickly. Are you with me? Okay, Asia, what's the sine? One. What's the cosine? Yeah, you're right, Asia. Just tell me what's the cosine. Yeah. The cosine is the y coordinate, sorry, the x coordinate. That's the sine. Okay, now 270. 180. That's the point that corresponds to 180. It's -1 and 0. Okay, so what am I doing here? What's the sine on 180 quickly? Sine of 180, 0. What's the cosine?
-1.
-1. Absolutely correct. 270. 270 is 390s. So that's the point that corresponds to it. That's a 0 and a -1. What's the sine of 3 pi over 2? -1. The cosine quickly is a 0. You don't need to memorize. If you understand the picture, you should be able to do that. Now, those, of course, you have to memorize. All right, so what's the sine of those angles? Okay. The sine of pi over 6 is a half. That's the piece you should memorize. And the cosine is the square root of 2 over 2, square root of 3 over 2. 60, flip them around. Okay. So if you memorize this, flip them around, you get the 60. Now 45 and 45. I will show you a little bit what is the number here and where it comes from. And this because it helps us remember a little bit what's the definition. So I'm going to scroll down and I'm going to focus on 45. So what's the sine and the cosine of 45? What's our definition? We take a point on the unit circle right there. That's the point on the unit circle that forms an angle of 45. The sine is the y coordinate. The cosine is the x coordinate. So basically, that's the cosine. And that's the sine of 45. Okay. Now I want to ask you a question. If this is 45 degrees and this is a right angle, how much here we have?
45 degrees.
Exactly. So what's the first remark can you give? This triangle is isosceles. It means those two sides are equal. It means what can you say about the sine and the cosine?
They're equal.
They are equal. Already you know that they are equal because it's the x and y coordinate. They have exact same value. Okay, sine 45, cosine 45 are equal. Part 2, what's their value? So since they are equal, I can call this A and I can call this A because it's the same number. Now, that's the unit circle. So we're going to try to figure out the sine and the cosine because it's easy for us. I'm going to use the Pythagorean. It tells me this side square plus this square equal to 1. Pythagorean theorem. Okay. You guys remember that? This side square plus this should equal to 1. So this will give me 2a squared equal to 1. I'm interested in the cosine. So what is a? A squared is 1/2. So a is the square root of that. Okay. That's it. It means that's the cosine of 45. That's the sine of 45. Now, that's the answer, but sometimes you write it in a different format. So this could be written square root of 1 over the square root of 2. It means 1 over the square root of 2. So this is algebra at this stage. Or a lot of people like to write it this way, and that's, I think, the book used. Say, okay, they don't want the square root of 2 in the denominator. They say, okay, I'm going to multiply numerator and denominator by the square root of 2. And then this will give me square root of 2 over 2. That's where the cosine and the sines are coming from. Exactly find the x and y coordinate of this point. And this will finish the table. That's square root of 2 over 2 and the square root of 2 over 2. Okay, and of this piece. All right. So if I go back to, are you guys done? Can I move this paper a little bit? Please say or no on chat. It will help me. Okay, so if I go down back to my unit circle, I'm gonna go back to my unit circle now. And I'm gonna fill in some details. Okay. If this is 30 degrees, what are the coordinates of this point? This angle is 30, that's cosine, so the x is the cosine, and this is the sine. The cosine of 30, you guys have the table in front of you. So this point is square root of 3 over 2 and a half. Because the x coordinate is the cosine, and the cosine is square root of 3 over 2, the sine is a half. This point on the unit circle, that's the 45-degree angle. It means that's the square root of 2 over 2 and the square root of 2 over 2. Finally, the 60. Okay. The x and y coordinate are the cosine and the sine. The cosine is a half, the sine is square root of 3 over 2. It means that this point right here on the unit circle is a half, that's the x, that's the cosine, and that's the sine. Now the question is, how can I figure out all the rest? Okay, so our goal today is basically to learn, not to memorize, how to figure out all the rest. So these are the most important ones. If once we learn those, everything will follow easily for the common angle. Right? So, question before I go on. Please ask your questions.
Wouldn't it? I mean,
I'm listening.
I've seen the unit circle before, but
I know.
what it's it would just be positive or negative based on what quadrant.
Exactly. Exactly. So, but we're gonna do it very clearly. Are you with me? Okay, we're gonna do it very clearly. So you don't even have to draw the unit circle. Once I ask you what's the cosine of 5 pi over 3, I don't want you to draw the whole thing. I want you to be able to figure it out immediately without even having to go to the unit circle. Because as you move on, you're not gonna drag this unit circle with you everywhere. All right, so to be able to figure out everything else, we're gonna introduce the idea of reference angle that I'm gonna use now and you're gonna use a little bit later on. Okay, so I'm going to talk about something called the reference angle, and then we go back and to fill the whole unit circle, which is, I know a lot of you have seen it, but you have to figure it out clearly. So there is a worksheet that, as usual, it's on Brightspace, which is worksheet for section 7.3, as usual, and I'm going to start reading. So we're going to talk first about reference angle. Once we do that, I'll go back and find the angle, the sine and cosine of all the common angle that we're interested in. Not all of them, some of them, because once you know the pattern, you can proceed. So reference angle. What is a reference angle? Suppose you have an angle theta. The reference angle associated with an angle theta is the acute angle. Acute means less than 90 degrees. That's what we mean by acute. Sorry, acute angle. It means less than 90 degrees. That's what I mean by acute angle. So the reference angle is the acute angle having positive measure formed by the x-axis and the terminal side of the angle theta. I did not say positive x-axis. It's formed by the x-axis and the terminal side of the angle theta. Okay. So now the problem is, for each of the following angles, sketch the angle given and find the reference angle. So if you guys, the worksheet is basically on Brightspace in case you don't see very well, but I hope you do. So I will start with the first one, and then I want you to work on the others. The first one. So what's the reference angle? Is the angle, the acute angle formed by the x-axis and the terminal side of theta. So 300 degrees Okay, what is 300? So 300 is like 60 degrees short of 3. So 300 is right there. Okay, that's my 300 degrees. So it goes from here all the way to here. That's 300. Okay, that's my angle. I drew my angle. The reference one. What's the reference one? The reference one is the angle formed by the x-axis and the terminal side of theta. That's what we mean by terminal side. So that's what we call terminal side of theta. The reference angle is the angle between here and here, pure and simple. So that's the reference angle. Okay, what's the measure of the reference angle? Is equal to what? It's positive. We don't worry about sign at all. We just want the value, the positive value. So what's the value here? If this is 300, it's the acute angle between the terminal side and the x-axis. So what is equal here? It's this one, minus 300, which is equal 60 degrees. That's what we mean by the reference angle. All right? Okay, let's move on. 2. I want you to do the same thing. Draw the angle. So remember now, 4 pi over 3 is how much? This is so you can draw them correctly. Okay, and then find the reference angle. You try it, and then I will do the work here. So to draw it, ask yourself, 4 pi over 3, if you're not comfortable with 4 pi over 3, how much is in degree? And then this will be very helpful because you should be comfortable in degrees. Ready? Okay, so this is 240. I want the reference, if I give you the angle in radian, I want the reference in radian. Okay, let's get that. Okay, 240. So what is my angle? So let me draw it. 240, so this is 180. I always use something. Then to get to 240, I had to get almost 60 degrees. So this is my angle. That's the 4 pi over 3. Okay, so what's my reference angle? It's the angle between the terminal side and the x-axis. I didn't say the positive x-axis. It's this acute angle. So in the picture, that's the reference angle. Okay, so what's the reference angle? Okay. 60. Everybody tells me 60. But since I gave you the angle in radian, I want it in radian. So it's how much in radian? Pi over 3 radian. Okay, it's this acute angle. That's the reference angle. All right, so, and the reference angle is really, we're gonna use it a lot. So that's why I want you to work with that. All right, 3 is easy, 135. I want the reference angle. I want to draw 135, tell me the reference, draw the reference angle, and then proceed. Okay, you have not more than 1 minute for that because that one is simple. I mean, they're all simple. Okay, what's the reference angle? Up 30 pi over 4, because 135 is right here. 135, we remember, it is right in the middle. That's 135. And I need this one. It's between the terminal side and the x-axis. So the reference here is 180 minus 135. because I want this one. The whole thing is 180. I took that away, which is 45 degree. Because I gave you the angle in degree, you give me the reference in degree. All right, 4. I'm giving time to everyone to basically figure it out. All right, who's comfortable? Who's comfortable to give me the first? Let us draw it. 7 pi over 3 is what? What's 7 pi over 3? Anybody? It's 420 degree. 420 because it's 7 times 6. So it's 420 degree. Now let us note that 6 pi over 3 is 2 pi. I mean, it's always nice to note that. 7 pi over 3 means basically you're taking 2 pi and adding pi over 3. So it means you're going around the circle once and then you're adding pi over 3. So, or if you think in degrees, 420, how far away it is from 360? 60 degrees. So 420 is what? You start here. So 420 is 360 plus 60 degrees. So if you want to draw it, you're going to start here. A full rotation around the circle, and then you move on by 60 degrees. That's the terminal side. So that's the reference angle right here, which is 60 degrees. So the reference is 60 degrees. Well, I get the last two problems. Number 5. 120, what's the reference angle? And this time I'm going to ask one of you, just to make sure. Okay. Angelina, are you with me? Angelina? I don't think so. Okay, Jeremiah, are you with me? Okay. I want all of you to have your camera on for a reason. Alex Baginski, are you with me? Alex?
Yes, sorry.
All right, no problem. Number 5.
Number 5 would be 2 pi over 3.
Okay, that's the value. I want the reference. So 120, where is located in which quadrant?
The second quadrant.
The second quadrant. So it's 120, that's 90, is somewhere here. That's 120. Where is the reference angle? In the picture, how can you describe the reference angle? It's the angle between what and what?
Between 180 and 90.
No, repeat. I don't think I followed.
Oh, sorry, I misunderstood.
That's okay.
I'm not sure.
Okay, we repeat. What's the reference angle? It's the angle formed by the x-axis and the terminal side of the angle. Okay? By the x-axis and the terminal side. So I'm going to go back here. This is 120. That's the terminal side. Do you agree with that?
Mm-hmm.
What's the reference angle? It's between what and what? The x-axis
80
and,
9 and 120.
right, that's the reference angle.
So it'd be 60.
Now we're talking. So the reference is 60. Is 180 minus 120. You have to draw it to know what it is. All right? Okay. Now, all of you guys stay with me. I want to tell you one thing. So once I ask a student a question, I forgot who I asked. So don't think I remember the stuff at all. I have so many students to remember something like that. All right, 6. Again, I'm going to give you 2 minutes to do it. Draw the angle clearly and give me the reference. Get going. And I'm going to ask one of you because I want every one of you to get that. Okay, I'm going to pick one of you. If you don't know how to do it, don't worry about it. We are learning this stuff. Lucas, are you with me? Lucas?
Yeah, I'm here.
Okay, help me out.
To be honest, I'm not sure.
Okay, 5 pi over 3. Where is it? If I want to draw the angle 5 pi over 3, where is it on the unit circle? In which quadrant?
I don't know. Clarissa said 300, so I'm gonna go with 300.
I can't hear you. Sorry.
I'm not sure, but Clarissa said 300, so I'm gonna
Yes,
say
why?
300.
Because pi over 3, what's 5 pi over 3? It's 5 multiplied by pi over 3. That's what it means. Pi over 3, this one you should know. That's the 60-degree angle. Are you following?
Yeah.
Then this will give me 300. That's how your classmates are figuring this out. So 300 degrees will put me where on the unit circle? In which quadrant?
Quadrant 4.
Fourth quadrant. So this is 300. It's going to put me somewhere here. Mean that, so this is 90, 180, 270, a little bit. This is my 300 degree. That's the 5 pi over 3. That's my angle. What is the reference angle? It's the angle between where and where?
Wouldn't it be between 360?
I can't hear you. Please speak up.
I'm sorry. Wouldn't it be 360?
No. What's the reference? It's the angle between the x-axis and the terminal side. That's the reference angle.
Yeah. So I thought it would be 360 that you'd start from. So you do 360 minus 300.
Right. That's
60.
the reference angle. A 360 minus 300, which is going to give me 60 degrees. Now, if my original one is in radian, I want this in radian. It means what's 60 in radian?
Be pi over 3, right?
Pi over 3. I want total memory of that. Is that clearer?
Yeah.
Okay. Now we are going to use those idea of reference angle to figure out basically this unit circle picture. We're going to figure it out without having to memorize. We're going to figure out basically all those points by using the idea of reference angle. And to do that, we're going to start another worksheet. And this is what we're going to do now. Like, I have theta equal 300. My goal is to find what's the cosine of 300 and what's the sine. That's really what I would like to do. But how I want you to do that? I'm asking you, for each of the angles below, do the following. Draw the reference angle in the first quadrant. It means find it, draw it in the first quadrant. Find the sine and cosine of the reference angle, and then use the symmetry of the unit circle to find the exact value of the sine and cosine for each of the angle below. So I will do the first problem clearly myself, I hope, and then I will let you work on it. All right, so my goal is to find the exact value of sine and cosine. And the only thing you can use is the following. That's the one I want you to use. That's what you can use. Pi over 6, pi over 4, pi over 3. It means 30, 45, and 60. The sine, you guys have those, and the cosine. A half, square root of 3 over 2. This is what I want you to use only. And a half. We're not going to use those numbers that we wrote them to find the sine and cosine of 300. So let's see how we are going to do that. Okay, first, I want to draw 300. 300 degrees, we know it is right here. So that's 270. So that's the 300 degrees. To be able to find the sine and cosine, I need to find the x and y coordinate of this point. But the way we are going to do it is like this. First, I want you to find the reference angle. So if this is 300, what's the reference angle?
$60.
60, because the reference angle is the angle between the x-axis and the terminal side. Okay, so that's the angle. So it's 360 minus 300, which is 60. Okay, right there. That's really what I want. Then I'm asking you to do the following. So that's 60 degrees. Draw the reference angle in the first quadrant. It means I want you to draw the angle of 60 in the first quadrant. So basically, I'm asking you to draw the same thing here. So this angle and this angle are the same. That's 60. Okay, we're almost done at this stage. So this is 130. Sorry. That's 300 here. That's my angle of interest. And this is 60, and this is 60. Now, what do I mean the symmetry of the unit circle? What I mean is the following. So what I want, my goal is to find the coordinate of the point P. Symmetry means that those points P and Q are symmetric with respect to each other. Okay. So now, my question is, use symmetry to find the sine and cosine of 300. So let us remember, the sine of 300 is y coordinate of P. The cosine of 300 is the x coordinate of P. Okay, that's the definition. The cosine is the x coordinate and the sine is y coordinate. Now I want to use the symmetry. What do I mean by that? That's a 60-degree angle. Now we know all about 60. If this is 60, it means that this is a half because that's the cosine of 60. And this is the square root of 3 over 2. Sine of 60 is a half. Sorry, cosine of 60 is a half. The cosine of 60 is square root of 3 over 2. So to find this point, how can I use the unit circle? What's going to be the x coordinate of the point P? What's going to be the y coordinate of the point P? Okay, is this point here. What are the coordinates of it? Can anybody answer this question? Total symmetry, because I have the same angle here, make those 2 points symmetric. If I know Q, do I know P?
Yes,
What's P?
1/2,
1/2.
negative
Same
3 root 2.
coordinate at that. That's the same x coordinate. The y coordinate is the opposite.
Right.
What does this mean? The sine of 300 is minus the square root of 3 over 2. The cosine is 1/2. So that's the sine and that's the cosine. All right, so let us, the first one look a bit complicated, but actually it's not. So what we do is that we take our angle, we find our reference, we draw it in the first quadrant. Our reference in those particular problems is going to be either 30 or 60 or 45. That's about the variation. I use what we know about sine and cosine of the common angle to figure out the sine of the cosine of the other angles. So 2. Okay, I want you guys to do 2. The angle is 4 pi over 3. I'm going to draw it on a larger picture for you guys. So we're doing 2. I give you like 3 minutes to interact with it, and then I take you from there. Okay. All right, anybody feel ready by any chance?
I can explain how I got.
Go for it.
Okay, so 4 pi over 3 is 240 degrees. The reference angle to that is 120.
1 minute, 1 minute. You have to go slowly so I can explain,
Oh.
repeat everything you say, okay? To make sure everybody understand.
Yes,
So,
ma'am.
4 pi,
So
don't call me ma'am. 4 pi over 3 is 240. She's absolutely correct because this is 4 times pi over 3. It is 240. Just to help you out. Now, before I let her go, and I would like you to start also thinking along those ways because it helps you. 4 pi over 3 is basically 3 pi over 3 plus pi over 3. This makes sense?
yes.
It means it's pi plus pi over 3. It helps you also to think of those along those ways. So either way it helps. So it's pi over 3 plus pi or 240. Keep going. So when I draw 240, where I am in my circle.
You are in the third quadrant.
Okay, so that's 80. 240, it means basically I am right here. Okay, that's 240. What I want is the sine and the cosine. I am on the unit circle. It means I need the x and y coordinate of this point. That's what I need. All right, keep going.
So we're in the third quadrant, and then the terminal side is the side on the right, and it's going to be the reference angle is going to be 120 degrees.
No. No. What's the reference angle? Let me remind you. It's the acute angle between what and what?
Would it be 60?
It will be 60. Okay. The reference angle is the acute angle between the x-axis, that's the x-axis, and the terminal side. That's the reference angle. Are you with me? Okay. So it's 240 minus 180. That's 60. Okay, it means this angle is 60. My goal is to find the x and y coordinate of this point. Very good. Now, what should I do next? Which reference? That's the reason they are called reference angle, because we are going to use them as reference to find the x and y coordinate. So what do I do now? I'm going to take in the first quadrant, draw this reference angle in the first quadrant. It means right here. Basically, I'm going to extend this, and the geometry tell me this is 60 degrees. So once I find it, I draw it in the first quadrant. Now, how am I using the symmetry? I take this point here and this point here. If I know the coordinate of that point, can I find the coordinate of the point P? That's really the question. That's how I'm using the symmetry. Those are symmetric with respect to each other. So if I know the coordinate here, I know the coordinate here. Now, if I call this point Q, this is my unit circle. If this is 60, the x coordinate is the cosine of 60. And that's the only one I want you to use. The cosine of 60 is a half. The sine of 60 is the square root of 3 over 2. So that's why I call it reference. So I use them, I refer to them to be able to find the point P. So now what are the coordinates of the point P now? What's the point P? I pick in Maddie. Maddie, are you with me?
Yes, I'm with you.
Okay, what's the coordinate of the point P?
It's going to be -1/2. Did you want the other one as well for the?
Oh, yeah, I want everything.
Okay, and then it's negative the square root of 3 over 2.
Okay, so now what's the sine of 4 pi over 3? Maddie, if you feel comfortable, keep going.
I don't have this next part yet.
Okay. I gave you 30 more seconds for everyone to figure it out. It's actually, the picture is in front of you. The sine represents the y coordinate. And the cosine is the x coordinate. So this one is the sine of 4 pi over 3. The coordinate here. So the sine is the y coordinate of the point P. By symmetry, the y coordinate is minus that. The cosine, that's the cosine, is the x coordinate of P. It means it's minus. So now I know the sine and cosine of this. So if you pick up your calculator and you compute cosine 4 pi over 3, you're going to get -1/2. Okay, all right, we'll do one more. I don't want you to worry about 4. Let's do 5. And then time will be up. Let's do 5. So you draw the 120. You compute the reference angle. You draw the reference angle in the first quadrant, and then you use it, you refer to it to find the cosine and sine of the given angle. Okay. Who's ready?
I'm ready, Professor.
Go for it. Where is 120?
120 is in the second quadrant, and the reference angle to that is 60 degrees.
All right, so let me draw it. So that's 120. That's 120. The reference angle, I repeat, it's the angle between the terminal side and the x-axis. That's the reference angle. So the reference is this one here. So it's going to be 180. You take away the 120. Okay, keep going.
So then that would be equal to the cost of -1/2 since it's on the negative x-axis.
So what do you do second? Because I don't want you to memorize. I want you really to always remember.
You would draw 60 degrees in the first quadrant.
Right. We'll draw 60 degrees right here. So we're going to draw this because I'm going to use this as reference to find this one. All right. This point, my goal is to find the coordinate of the point P. That's the point on the unit circle. That's the one I want. Okay, what are the coordinates of that point? Keep going.
The coordinates of that point are x -1/2. Wait, oh, you want
No.
for 60 degrees?
I want the 60. I want the reference one.
1/2.
1/2.
Square root of 3/2.
Square root of 3/2. Now those two are symmetric. I mean, just the symmetry of the unit circle. You have the same angle here. This will make those two symmetric. So what are the coordinates of the point P? Keep going, you're fine.
The coordinates of the point P are -1/2.
Yeah.
X, and then y is square root of 3/2.
Yeah, the y coordinate is the same. And the x coordinate, as you realize, if this is 1/2, this one is just opposite to it, will be -1/2. Now, what's the sine of 120? Remember, this is 120. It's from here all the way to here. That's the 120. That's the 120.
The sine of 120 is the square root of 3/2.
Yeah, so the sine of 120 in terms of coordinate, and then the answer is what?
Square root of 3/2.
I know, you're right, but I want something in between. That's what I want.
Oh, y.
That's what I want. It's the y coordinate of the point P.
Okay.
It means the square root of 3/2. And the sine is, the cosine is the x coordinate of the point P, which is
-1/2.
-1/2. So that's the sine and that's the cosine. Okay. All right. I forgot that I should show you something. I'm sorry, I'm a little bit over time, but I have to show you that. On your calculator, I don't know what calculator do you have, but if you're finding the cosine of the angle, you should be in the correct mode. So what do I mean by that? So if, let me take cosine. So my calculator now is in degree mode. So if I want to cosine 30 degrees. No, I want the cosine 60. Cosine 60 degrees. This is, give me 0.5, which is a half. But let us say I'm working in radian. Okay, now 60 is pi over 3. But if I enter cosine pi over 3, it's going to treat pi over 3 as degrees. So to be able to get cosine pi over 3, I have to go back to mode and put the calculator in a radian mode. So I go to mode right there. Then you scroll, that's on my calculator, and then you go to radian and then you enter. So if I'm working with radian, you have to put your calculator in a radian mode. And now I can go back and now I compute the cosine of pi over 3. And now I'm going to get 0.5. But I have to put my calculator in radian mode to be able to do that. So if you're working with so this is very important for us starting today. Okay. All right. So for Monday, I think you're going to have your quiz 2 for Monday. Okay, and you do the practice verb, the homework I assigned to you. I may ask you to finish this worksheet and I will assign some problems from the book to do them. Okay, and what else? Remember, you guys, that I have office hours. None of you is showing up. Please show up to my office hours if you have any questions or whatsoever. Or email me if you cannot make my office hours and I can set up like an appointment with you over Zoom and answer your question.
Quick question. What will quiz 2 cover?
Oh boy, quite a bit. I will write it clearly. It's going to cover, definitely, you have to know the definition of sine and cosine. Sure, definitely that. Then it will cover questions like the following. Find an angle different from 40, but to have the same sine as 40. So you reviewed the worksheet we did before. Find an angle different than, I don't know, 50, but have the same cosine as 50. So I will ask probably a question along those lines. Second, I will definitely ask you a question converting from radian to degree. How to convert. You will have, but that's what in my mind right now. I'm thinking about what I taught you. The arc length. Okay. And one question I may ask, I'll give you the unit circle. I give you, or necessary, not unit circle, any circle, it could be radius r. I give you a point. And I tell you find the exact coordinate of this point. Basically, I want to make sure that you know that if you take a point on the circle, if it's of radius r, then the coordinate is r cosine r sine. So I want you to be able to connect those dots. All right. So basically, go over your practice problem and the worksheet I did. I know it's a lot of material, but this is really the ABC of the course. If you guys are with me now, you will be all right in the course. We're building the course right now. Any other questions? Anything else?